right, cool. So what is it about number 6 that confuses people? My question is, did you realize that this is the exam number 2 review? So, right, so hopefully you realize there's 2 parts. There's 1 and 2. The first one is a future value using this formula right here. Whoops. 1 plus I and minus 1 over I. And then the second part was second account paying compounded continuously, that you're supposed to be using this formula right here. So I guess the first question is, for those that were stuck here, who did not get this portion right here under purple correct? Or what went wrong there so I can help with there?
Wait, could you write out the question?
Oh, write out the question?
Yeah, I don't have the paper.
The questions are right here. No, that's fine. It's I'm not gonna write it out. I'm gonna just show it to you right here. It is right here. Number 6 is right there where it says suppose. So if you need to copy down the key informations, I'll leave the screen up right there for a moment for anyone that needs to. And then once you're done, say something, otherwise I won't know. Please.
Professor?
Yep,
How long do we have to take the exam?
a week.
Oh, sweet.
Are you putting up a mock exam to review?
This is the mock exam review.
I thought this was the homework questions.
These are not homework questions. Homework questions were the ones that we did on Tuesday.
Okay, fine. I'm finished writing it down.
I'm sorry, say it again?
I'm done writing it down if you want to.
Oh, cool. All right. Yeah, that's why it's in the appendix section instead of the problem section of the chapter. Yeah. So what was it that we had a question on for number 6? Sorry, I didn't write number 6 here. This is number 6. So what is it about this that we have a question about? Right? Do we know what the variables we're supposed to plug in? Do we know, were we unable to punch it in the calculator correctly? Are we, what's the question here? Or what's the part that's, sorry, go ahead.
Why are we using F equals PERT in this?
The reason is that the question states that after you figure out this number right here, right? Whatever the answer is, I can write that right here actually, because, oh wait, no, I don't know the answer right here. Well, whatever this answer is, right? Future value equals answer.
Mm-hmm.
This question is saying that you've taken this answer. So this is like bank account 1. And then what happens is that it's going to translate to this one by being your new deposit in bank account 2. The reason you know that it is the compound continuous equation, or F equals PE to the RT, is that here it says that then you take the total amount and place it into a second account paying 3.27% compounded continuously. So remember the key word here is continuously right here.
So if it says compounded continuously, it's always going to be this formula for the second one?
It's always going to be any formula related with your formula sheet having to do with the second row. You just have to remember which variable to solve for. But I can already tell you right now that the only variable you have to be concerned about is this form of the equation.
Okay.
Right? Because if anyone is looking, if anyone and everyone that's here should be looking at their formula sheet, you should have it written anywhere from the first exam that the second row, any of those equations, that involves compound continuously, because there's no such thing as compound continuously for annuities.
Mm-hmm. I got it now.
Right.
Yeah, I just used the wrong formula. That's why I got it wrong on when I was doing it before.
Oh, okay, perfect. Okay, good. So there was, sorry, I didn't recognize if that was Karen's voice or not, but someone else, I think it was Danny, that said she had a question on 6 as well. What other questions did you need me to clear up on that, if any?
It says like 30 years and then it says 10 years. So are we doing FV? Like, should we add the 10 or we have to do it twice?
Right, I see you now. So for the purple here, ooh, that was loud. It's a total between these two of 40 years, right? In total, 40 years in total. But then I specifically stated that this one is going to be 30, and then you multiply by the compounding period as you normally would, which means that the remaining 10 years, if you list the variables here on the right-hand side in navy, right, F is what you're looking for, P is the old answer, right? And then that means that the T here would be 10. So nothing is done twice. You're just doing it two different parts. And by doing it, it adds up to 40 years because you finish 30 years on the first part, done. Move over to the second bank, another 10 years, then done. So nothing has to ever be done repeated. If anything is or has to be done repeatedly, you'd be notified. But this is more like a transition, right? You had one transaction. It took 30 years. Then you move that money or the funds to a second transaction, and then it takes another 10 years there. So that's how the time plays out.
So would, what do you mean, like, because you said this answer for your FV becomes P in the second part? Like, so your F, whatever you get for FV is your new P?
Correct, right? Because what happens is that after 30 years, say you come to me and you said, hey, I want to bank with the Bank of Cato, and then I go, cool, your balance now after 30 years is $1 gajillion. And you go, okay, cool. I don't like you, Bank Cato, anymore. I'm gonna go to bank whoever now. So you're gonna take all your $1 gajillion. The second bank doesn't know what your history is like. All they know is that you're gonna give them $1 gajillion. So as far as the second bank is concerned, your starting point with them is $1 gajillion. Is that a little bit more clear?
Well, what about like the two different compounded like percentages? Like, where do you put the 3.27 in the F equals PERT?
This one here, this one is pertaining to the point, oops, I forgot the 0.0654 over the compound period.
So
And
when
then once you're done there,
Okay.
you have the what you said, which was the, where is it? Then you use 0.0327 here, right? It's like, yeah, it's kind of like, or like, you know, when you're doing photo shoots, right? Well, if you have photographer one and they're like, okay, I want you to do it this style. And then you're done with photographer one. And then all of a sudden you move to photographer two and they're like, no, I want a completely different style. They give you a new wardrobe, a new everything, whatever. You got to do it their way. So you're the same person. In other words, you're your same money. But when you're working with photographer one, you got photographer one, sorry, you're doing it a certain style. And then when you move to photographer two, you just bring you, and then everything else you do it their style. Or studio even. Studio probably makes more sense. Okay, what are their questions on number 6? Just number 6 for now. Don't worry, we'll have time to do the other problems.
Sorry.
Sorry, I couldn't hear that. One more time, please.
The interest accrued at the end, like what formula do I use for that?
Gotcha. So the interest accrued, you have two ways to do this. The easy way is just to do it like this. Okay, it's basically whatever this answer is. The final answer from the second account or account number 2, however you want to think of it. And you're going to subtract off, hold on, let me see. You contributed $200 every time. And then you're going to, and it's just compound monthly. Yeah, so CP is 12 here. I wrote that up there, good. And you're going to multiply that by 360. And 360 came from this right here, which is, again, remember, total number of periods / payments. Remember, in slang, this is your total, including interest earned, including, sorry, I'm gonna scroll up just a touch, interest earned. So that key component is understanding that it's included. This is what you contributed, your contribution, right? Your pocket money, if you will. Oops, forgot the B in contribution, contribution. Okay, and this is how many times? How often, if you will. Now, I mentioned this briefly in class, but if you did this the traditional way being, I'm gonna write this in orange, where you took, I'm starting on the right side where the Navy. If you took F minus P, right? And then you went back to the left side now, which is the first equation, and you did it the way we learned it here, FV minus R times 360, right? So if you took both these orange statements and you added them together, that will give you the same exact result as this. So in other words, both of these provide the same answer. Okay, I heard I'm confused, which is fine. Let me just write this first really quick, provide the same answer. Okay, so let's take a step back. What part are we confused about? Someone's confused, I know that.
I'm good with it. I got my answer. Thank you.
Okay. I thought I
Can you
heard someone
explain
mum.
where you got the 200 from?
Sure. In the question, if you flip back to it, it says that suppose you put away $200 every month.
What page is
Okay, thank you.
this question on?
Yep, no worries.
Page 39.
Thank you.
It's on page, yeah, thank you.
Wait, in your textbook?
In my textbook, yeah.
Okay, thank you.
And Professor, for the F equals PERT, like we're putting in E, obviously, right?
E as in the, gosh, I don't have my calculator with me right now, but it's the E function, you know, the E raised to the power in your calculator.
Mm-hmm.
Yeah, remember, depending on your calculator, if you push E with the little caret and you try to hit equals, it should give you an error. If you push the E by itself and you get a number of 2.17 or 2.71, that's the incorrect E, if that makes sense.
So do you do this do you do this interest accrued also for like when it says like after maturing? Is it the same formula?
After maturing is generally when you're looking for the total amount. Interest accrued is only interest accrued, right? So when anyone asks like, hey, what's the form? Like if I ask you, here's a quick example.
Mhm.
Example 1. If I say you put away $10,000 every year at 4% compound annually, for 20 years, and the question asks you, how much do you have after maturity, right? What is this question asking for? So I'm already going to tell you right now, it's a future value question, but are you solving for the future value or the recurring payment?
The
Anyone?
recurring?
The future value.
It's the future value, right? Not the recurring payment. It's this guy. Why? Because we're putting away 10,000 every year, which is this. So we can't solve for R if we already have R, right? Ladies and Lim, I don't know if any other gentlemen got into the classroom. But right, you can't have your cake and eat it. So if I give you the recurring amount, which is $10,000, right, you can't solve for it. You're already putting away that much every year. So therefore, when it's asking how much do you have after maturity, that translates to how much do you have after the 20 years. That's the future value.
Wait,
Then to dial it back to answer the question about interest, I have to ask you how much interest was accrued. And this example that I just typed right now does not ask that. So you only answer the interest question when it's being asked of you. And I interrupted whoever that was. So sorry, you can ask again now.
Sorry, that was me. I put in all the, like, what we were supposed to put in. I'm still getting the wrong answer from what you have up here.
For which part? For number 1 or number 2?
Well, I put in everything for number 1, and I got 222,963.16. So
Give me
then
a sec.
okay.
200 and what?
222,963.
222,000? Oh wait, I'm sorry. 222,916 and how many cents?
963 and 16 cents.
Oh, 63, I'm sorry, 963. Okay, so before you move on, I think that's Danny. Can anyone else confirm that answer? Because I don't have that middle answer in my textbook, I think.
Yeah, that's right.
Okay, so that's good. That's right, Danny. And then what you do is you move this over here and you plug in that answer and you use this equation right there on the right-hand side of the screen.
And I'm not, for that, I got 2,303,745.
Let me try it myself. 222, because that does not match what I have in the back. Times e to the 10 times. Did you remember to change your decimal to, your percentage to a decimal?
Mm-hmm.
Then you're typing something wrong on your calculator. You're gonna have to show it to me, take a picture and send it to me on Remind, and I can take a look at it right now.
Okay.
Yeah, because with that future value correct, multiplying by e to the 10 times 0.0327, that does give the answer that I have listed here. 309,205.68. Oops, it's 68, not 64. Did I do something wrong? 222,963.19.
It's supposed to be
You,
16, not 19
it's supposed to be what? I'm sorry.
cents. On your first answer, I think you put 19 cents. It's 16 cents.
Oh, thank you. $64. Okay, yes. Thank you for catching that. I definitely misheard. Okay. Okay, let's think. So I'm gonna pull up Remind here. That's why. So remember, Danny, you weren't in this particular class. When you put the 2 parentheses split like that, it's thinking raise it to the 0.0324 or 27. That's a 7 there, by the way. And it's telling you to not multiply by 10 in the exponent. The 10 multiplying has to be in the exponent as well.
So just 0.0324 and then times 10, just no parentheses.
Yeah, let me type it out for you really quick.
Yeah, it's 724.
Wait, 4 or 7? No, 7, yeah. Oops, times 10. So like that. Yeah, that's a 7 right there. Just in case if people are misreading this.
Okay.
0.0327. Okay. Anyone else have questions on number 6?
I have a side question. If anyone
Yeah,
has-
that's fine.
Do you mind
Yeah,
going?
side question, and then I'll do number 8 because I think someone else said that too. I'm sorry, I interrupted you. Go ahead.
For the formula sheet, do you mind going through it and just like clarifying when do you use each like equation, like each row?
Yeah, sure. Okay. Okay. So I'll do that one really quick because that one's easy, right? So if everyone's looking at their formula sheet right now, right? What does the first and the third row share in common? What do they both need?
CP.
Perfect. So you have to have a compounding period on both of those. The second row that I just mentioned very briefly earlier, right there, you only use the second row when it says what? Compounded
Continuously.
continuously. Perfect. Okay. Now, last one. How do you know to use the third row versus the first row? They both have a compound period, which is like, oh crap, I'm stuck there. But how do you differentiate? Or how do you tell them apart?
The reoccurring payments.
Right? So the reoccurring payments, or the R, is only available in the third row. Okay? That means that the first row all are one-time deposits, single deposits. They're single tens, they're one dates, there are no continuous dates, they are just one and done, okay? Which also means that, and I'll just tell everyone right now, that means for the third row, the first two have to do with the future, the second two in this, the third and fourth row column in the third row have to do with the present. And remember, you know that you're solving for a future or a present because you're looking for the big amount, the large total amount. You're solving for the R is that when you have the total amount and you're looking for what the recurring payment is. Effective interest rate, you don't have to worry about it for the second exam. So you don't have to worry about that last one.
Okay, got it.
That sounded like Tina. That was good?
Yeah, thanks.
Okay. Number 8 is asking what? Okay. Number 8 is another future value problem, but there's just one little caveat you have to worry about. That's all. And it's the following. So number 8, they tell you you're going to give up $2 per day, right, for soda. But they say, or I said, assuming, sorry if I'm speaking loud, I'm just getting really excited. Assuming 30 days in a month per month, right? They want to know how much is in the account, what is in the account after maturity, right? In other words, you're looking for the total amount. My problem says that you're compounding monthly, right? But you're saving $2 every day. So what's the recurring payment, right? I already told you you're looking for the future value. The recurring payment is just your $2. And you might go, well, wait, that's per day. You're compounding monthly. Well, how do we compensate for that? The fact that I told you to assume 30 days in a month. So in other words, your recurring payment should be 60 in this problem. So that's probably what people were confused about. Everything else should still be the same, right? I is equal to 0.066 divided by 12. N is equal to what? How long did I say? 20 years. And you should be using this formula already, right? You don't have the total amount, you have the amount that you're putting away per month. That's how you can tell if you're using the, what do you call it? Whether you're looking for the total amount, in other words, future value equals versus the recurring payment, which is R equals. You can't look for R because you already know R. R is $60 per month. Yes, you save $2 per day by giving up soda. However, I'm also telling you that by giving up those $2 per day, you put away the saved money every month. So it matches the compound period. Just in case, interest accrued again, I asked you here, it would be same way, which is the future value minus 60. Where did 60 come from? Remember, that's a recurring payment right there. And you're multiplying it by 240. Why 240? That's this answer here, right? But what does that answer mean again? Remember, this is total number of what? Payments or periods, however you want to think of it, right? You're putting away $60 every month, 240 times, AKA every month for the next 20 years. I think that was Danny's question. Is that good at number 8?
I have a question about maturity. Like, what's the
Yeah.
formula for it? Is there a formula?
What do you mean? When I ask for maturity, it's just asking you what is the amount after the time has been exhausted. It's a terminology, or
So
it's
you-
a phrasing.
So you basically just solve it, and then that's the answer.
Yeah, it's kind of like saying when I say find the sum of the following. What does sum mean? Anyone? Add, right? But then if I said add the following, find the following, or I say, or I give you 4 plus 2, and then I say find this result. Oops, not fin. Find this result. There's no formula for result, right? It's just a phrase saying, hey, find out what this is. Same with maturity. Maturity has never been a formula. Maturity just means find what it is, what you're looking for. It's just a financial way of saying it. Like your money matures, quote unquote, after it finishes its lifetime in whatever account it is. In this case, what is that, 20 years? Yeah, 20 years. It's just like us, right? We normally hit maturity after a range of 16 to 18, right? It's not an exact period in life or something. It's just once you're done going through whatever it is, in this case, mostly puberty, right? Yeah, maturity is not an actual formula of any sorts. It's just a phrase. What other
Okay,
questions?
thank you.
Yeah, no worries.
How do you know to multiply by 2 times 30, where you have R?
For that one, because the question, maybe it would be better if I flip to it. Apologies for that. If you look at number 8 right here, right? It says you plan on giving up soda, which saves you $2 each day, assuming 30 days in a month. But the problem here is that if you read, it says you take those savings and deposit on a monthly basis into an account paying 6.6%. So are you putting away $2 every month, or $2 that you saved every day at the end of the month?
I don't know, I'm still confused.
Which part?
Like, how would I know the difference on the exam?
Well, because it will tell you, you put away blank each month, each week, each year, each quarter, versus something that says, oh, okay, you have this little mini calculation, and that can happen how frequent it can, but it doesn't match how often you're putting away the deposit. See, I guess the key point here is the fact that you have $2 each day right here, right? And that does not match depositing on a monthly basis. So how do you make $2 match the monthly? And that's because I gave you the fact that there's 30 days in a month, right? What you deposit, how frequent that is, must match the compounding period.
Okay.
So if you have an account that is paying 5% per year, just like this, I wrote right here, example 1. See how it's put $10,000? I forgot the dollar sign right there. You put $10,000 away every year, compounded annually, right? That is no mistake. These are supposed to match. Well, what if I don't say you put $10,000 every year? What if I said, oh, hey, you saved $500 every month, right? you go, but wait a second, I'm compounded annually. How can I put something away annually when I only have $500 a month? Well, how do you kick it up so that $500 a month represents per year? You take 500 and multiply by what?
You multiply by. Yeah, I missed the question.
That's okay. The question is here I have written down, you put away $10,000 every year and it at a percentage compounded annually. When it matches like that, that's the easiest, right? R is R. Answering the question, like how can you tell on a test or even reading a question, right? If, I'm gonna put an if here. If I said instead, 500 per month was saved, dot, 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 but you refer to this question still. How do you make it so that 500 per month matches annually instead of per month?
You multiply it by 12.
Yeah. So that's the same exact thing we did the other problem. The other problem said, hey, you save $2 per month, but you're not taking the time to go to the bank every day to just put $2 measly in the bank. What do? You go, okay, $2 per day. I'm gonna put it away every month. Well, where did I get 60? Oh, it was $2 for every day of the 30 days. Same thing.
Okay, got it. Thank you.
Mm-hmm.
Are
What
you
other
able
questions?
Sorry, are you able to solve number 8? Because for some reason I keep getting the wrong answer.
Sure.
Thank you.
Did we get all the, does your setup look correct at least? Does it look like this? So I'm gonna cross out this. And then going from number 8 still. Does your setup look like this at least? Future value equals 60. 1 plus 0.066 minus 1.066. What is it? 240? Yeah. Does it look like that?
Oh, I didn't include the -1 in the parentheses. Should I, like, once putting it into the calculator? Or is it like...
You definitely should. You definitely should, yeah, depending on what kind of calculator you have. The -1 is part of the formula for a reason. You definitely don't want to start straying away from what we normally would do. So for anyone else that's having an issue with their calculator, you should practice it right now and see if it's working. If not, it's either because the syntax is messed up or there's a missing parentheses. If you're on Remind, you can take a picture of your calculator and send it to me really quick. I have my phone right next to me, so that's not a problem either.
I'm getting like close to the answer, but it's not. Like it's 1,000 off, so wait, never mind. I don't know.
Wait, what's the right answer?
The answer for that one should be 29,780.80 cents. Let me write that down.
Thank you.
Are you able to type out the syntax maybe, and I'll see if I'm putting it in correctly?
Sure. Step 1 is this. Parentheses 1 plus 0.066. Wait, why don't you just send me a picture of it?
Oh, I'll send you a picture.
Yeah. I can tell you exactly right away. Unless everyone else wants to see this too. But that's what it's supposed to look like. Oh, equal sign. Oops.
Thank you.
Yep, no worries. Nope, that's the wrong one. Here we go. Never go. Ooh, that was bad. Were you able to get the answer now?
I'm like, I'm almost done putting it in.
No, it's fine. Take your time.
Now I keep getting the wrong one, so I'll just send you a picture.
Okay,
Okay, thank you anyways.
no worries. Okay, next question.
Can we go on number 9? I just couldn't figure out how to do the interest owed. I got the right answer for the first part though.
Lovely. Okay, so number 9 right here. Did it look like this? So just in case if people aren't looking, the recurring payment is $19,660.28. And they told you that, was this a compound monthly? So they told you compound monthly is 12. And also the fact that you're doing this for how many years? 10 years. So this is a present value problem already, if you didn't know. Okay, you're granted 2 million. So what do you do when you go interest owed or pay back, right? It looks like this, interest paid back. It looks super similar, but it's basically the recurring payment times the total number of payments.
Where did you get the 19 from? 19,600.
That's the answer to the problem, the first part,
Oh,
right? It's the answer to this. Let me do a different color. How do I want to write this? 0.0. What's the percentage? 0.03.
0.03375.
Thank you. 1 minus 1 plus 0.03375 over 12 raised to the negative 10. So that's negative 120. That's where R comes from.
okay, thank you.
Okay, so then in this case, it would be, sorry, I didn't recognize whose voice that was. It's your 19,660.28 times 120 minus what they originally granted you, which is in this case 2 million here. What went wrong here, if you don't mind me asking? Did you flip the variables?
I didn't do it because I just couldn't remember which formula it was, so I didn't get any answer for it. I'm doing it now.
Gotcha. So I said this in my last lecture yesterday morning, but of course I don't expect any of you to wake up at 9 a.m. to see it. But here's the rundown, right? I think I've written down this before, but I'll write it down here for this lecture as well, or this review, if you will. Remember, it's only 2 cases, right? There's the future and there's the present. Okay, and then when you talk about interest, they both require interest. But this is the monetary amount, right? This is the money, not the interest rate. So in present scenarios, you owe. In future scenarios, you earn. And then the equations, I never write them out because I think it's better if you just think about it, right?
Does that take total number of pays for interest paid?
Yeah, like payments,
And what would we put in for that?
N times CP.
Oh, okay.
Nope, wrong one. Times total. You guys scare me when you ask questions like that. Okay, so the thing to remember here for the interest component, right, is that when you're earning interest, R is what you contribute, right? If you're earning interest, this is what you contribute. Which means that the interest is built in here, right? You're not paying yourself interest, the bank is.
Mhm.
Right? So you can't flip the order of that. Whereas in present, right, the interest is built into the payment. Why is that? Well, when you were loaned or lent this amount, if I lent you each $1 million, am I going to give you any more than $1 million? No, the contract says $1 million. It's exactly $1 million, no more, no less. So when you pay me back, you're paying me back plus interest. So that means it's the payments. Payments, in other words, the way to think of it is that you're paying off the principal plus interest. And that's how you can tell those two apart. I don't know. I mean, if we talk about this in everyday language in terms of without formulas and you talk about your bank accounts, each and every one of you will be able to understand it. But for whatever reason, when you see it written down, people freak out, right? You go like, oh my goodness, I don't know what this interest means. You know, they start doing weird things like they start giving me this formula right here, right? That's the interest rate. That has nothing to do with money, right? Don't do that. So if it asks you for interest, right, they're asking for, in that sense, right, how much money was earned? How much money did you have to pay on top of the loan? You know, that type of thing. So hopefully that helps a couple of people right there.
Thank you.
Mm-hmm. What other questions do we have?
Could you do 10 too?
Let's see what number 10 is. Ah, okay. So this one is nice because you can do this one of two ways. What are the two ways that you can do this? Friend one. Friend
Can
one.
you scroll up a little bit?
Oh,
Thank
sorry.
you. That's good. Thank you.
Friend, and then there's you. Okay. It says that your friend can put away $30. You can put away $50. They tell you that the compound period is 52 because you're putting it both away each week. 4 7/8 is the percentage. Someone tell me what that is. 0.04 something 875. And you're doing this for 40 years. 40? Yeah, 40. Times the CP. I need to know what the rest of that decimal is. It's 7/8.
Wait, is I equals 0.04?
04 something. Someone hasn't told me the rest of the number yet.
0.4875.
Ah, it is 875. Thank you. I just wasn't sure. Okay. So if you're putting away 50 each week and your friend is putting away 30 each week, what are we solving for? The future value or the recurring payment? Ding. No, not okay. That's not the answer to my question. Are we solving for the future value or the recurring payment?
Recurring payment.
But the recurring payment is 30 per week and you 50 per week. So you already have some kind of recurrence there.
Some future value.
Future value, right? You're telling me that the future value is $30 for one friend and $50 for you. You're putting that away every week, right? If you're putting it away every week, that's the recurrence, right? That's the repeated part. That's the multiple payment, the whatever you want to call it, right? So future value is what you're looking for. Yeah. Okay, so there's that. Now, two ways to do this. What's the recurring payment? Well, You can do this twice with 30 or 50 and then add up together, or you could just start right here and add it right from the get-go. And then just fill out your formula and then calculate on your calculator. Right? So you have to realize that there are two people here contributing, friend and yourself. You can do the separate calculation twice because it just feels easier for you, even though it's the longer way. But I'm telling you right now that you'll get the correct answer if you just combine the contributions right here from the get-go and do the calculation once, and you'll get the right answer. Do we need to see this set up in the formula?
Yes, please.
Ah, you're killing me. 5, 6, 7, 8, 80. 1 plus 0.04875 over 52
You also do the
minus 1.
calculator syntax for that.
Sure. I am very worried now. What's 52 times 40? 2080. Okay, syntax is like this. Parentheses 1 plus 0.04875 divided by 12.
Isn't it 52?
Thank you. 52. Yay, someone's paying attention. 2080. No, I don't have enough room. Sorry, I'm gonna rewrite this. I have to scroll down. I was trying to fit it all on one page, so sorry for those that are still writing. Okay, let's try that one more time. So here's the syntax. Step 1. Step 1, parentheses, 1 plus 0.04875 divide by, let's make sure I'm paying attention this time, 52 caret 2080 minus 1. Remember, this minus 1 is not in the exponent. 2 times 80 equals 3 divide parentheses 0.04875 divide by 12 equals sign. So for those that need to, crank that out, make sure you get the right answer, all that jazz.
Is there any way, like, 'cause I feel like what was helpful for like studying for this on page 39 was seeing what, like, you wrote like FV equals, you wrote like present value equals, like on the exam, are you going to have like that?
You mean labeling it for you?
Or yeah, because it just helped us like to know which equation to use, basically.
I mean, I'm not going to give you, I mean, you'll have the equations, but I won't tell you, I'll tell you indirectly which the equation you're supposed to use.
Okay.
Are we gonna have one free answer on the exam?
No, it's just going to be really short, and then you're just going to do all the problems.
Come on.
I keep getting error when I type in the first part.
1 parentheses 1 plus 0.04875 divided by 52. Oh, because there's an extra parentheses here. Sorry, that was my fault. There you go. And got them all right. Do you think I'll be okay? If there's error, should I do 11 to 13 for triangles? Oh, what's 11 to 13? All right, cool. So yeah, someone let me know if the answer comes out okay, and then
I don't know if I'm putting it in wrong, but I keep getting a different answer. But I wrote everything that you just wrote on the syntax.
just take a picture and send it to me.
Okay.
One at a time. So I would do the first row first, and then
So in the second part of this, sorry, the third part of the syntax, why is it divided by 12 if it was divided by 52?
because I messed up.
Got it. Okay.
Try that now, Danny.
Thank you.
Okay.
Oh wow, I just got a random student that's asking for me, where are you teaching statistics? It's like, well, I'm not teaching statistics this next semester.
Yeah, I got the right answer now.
Yeah, that was my fault, sorry. All right, everyone cool there? Or as cool as they can be? All right, what do we want to see next?
What's the correct answer for this one also?
Oh, sorry, let me write that down. So this is number what? Number you and a friend. So this one should be 5,936.
Thank you.
You're welcome. $1 million. Man, Blackboard is so wonky. I hate this crap. 0.02. All right, what other questions do we want to see, if any, or ask?
I have a question on one of the old homeworks.
That's fine.
Okay, so let me just get back to it. 1 second.
3 years.
Reviewing them.
Oh, that's good.
Are you able to do 23 on, I forgot which page it is. Let me check.
Wait, so Professor, the exam is due back next Thursday?
Yeah, whatever 7 days from today is. So I'll give you until like what, 11:59 p.m. next Thursday. Don't leave it until then.
No, I know.
Are you able to do 23 on page 21?
Yeah, let me take a look at it.
Thank you.
This is on my textbook, right?
Yeah.
All right, cool. Oh, it's the same exact thing. Okay, cool, perfect. So this is my textbook. My text. Page, what is that? 21, number 23. Okay, 21, number 23. Okay, so what is it about this problem specifically? See, so you can see that it's like a part 1 and a part 2 again, right? So did you get the setup to look like this at least? 300, 1 plus, what is that? What the hell is 3/8? 3 divided by 8, 375. So 1.0, what is that? 4375 per month. Yeah, in a month. For 30, which is 360 minus 1.04375 over 12. Did you get that at least?
Yeah.
Okay, good. So assuming that your answer is correct, then the key component is this right here. I'm gonna write this in a different color so it stands out, right? This tells you that you're now in a different savings account and you're earning 0.0634 compound monthly. Well, which formula can you use when you have this kind of interest rate? Again, this is like matching to Tina's question saying, well, how do I know which formula to look at? Well, the only row that you can do is either the first row or the third row. However, you know this is automatically the first row for F. And the reason is that when you move, anyone for that matter, when you move this answer, whatever it may be, to this P, how many times do you do that? In other words, the question says you put $300 a month away for 30 years, and then after the total has accumulated, you put it into a different savings account for an additional 20 years. So when you move from account 1 to account 2, how often do you do that move? Anyone?
Once?
Once, right? So if it's a one-time occurrence, it has to be, since there's a compounding period, has to be first row equation, right? It can't be an annuity again because you're not doing this every whatever. So the equation you should be using is this one right here, right? Or in other words, you can just remember that during lecture, I've never moved from one annuity to another annuity because that doesn't make sense, right? Imagine, if you will, that any one of us can afford to put even $100 away per month after 30 years. And then all of a sudden we get an answer and the answer is going to be massive. It's going to be like hundreds of thousands of dollars. And all of a sudden you're going to put hundreds of thousands of dollars into a second annuity every month. I don't have hundreds of thousands of dollars, right? I have hundreds of thousands of dollars to put away one more time, sure, but in a single sum though, right? So it doesn't make sense that we move from an annuity and all of a sudden we have money out of nowhere in a larger sum amount to put away in a frequent basis again. What did you get as the answer for this one? Because I don't remember what it is. I have the total answer, but not the complete answer. What is the future value here? Just in case if anyone was wondering.
I got 1,299.10. I'm not sure.
Wait, only 1,000 or 10,000 or 100,000?
Oh no, I guess I got it wrong then. Only 1,000. Right.
So this one should be a lot more than that. Let me see what it is. 1 plus 0.4375 divided by 12 raised to the 360, right? That doesn't make sense, right? Because how is it that you put a $300 away every month and you only come out at 1,000? It should be 222,713,97. So this number now goes here, and you just do the same exact problem, but with the second part of the formula, not the annuity again, right? So if you ever have a problem that transitions from one to another, right? it doesn't make sense to go from one annuity to another annuity because yeah.
Professor, for the F equals P 1 plus I, like we'd still have to do add the CP there, right?
Right. Just the same exact way that I wrote it there on the letters. I mean, yeah, next to the letters, 0.0634 divided by 12. Everyone knows what the division symbol is on on a computer, right? You know which slash it is? It's the one where the question mark is.
What was the final answer for the F equals P 1 plus I?
Let me find out. It's in the back of my book. I gotta just scroll down to it. This is number 23. Nope. Nope. Okay, 23. Total should be where the heck is it? Oh, there it is. 7, 8, 8, 8, 2, 9, 67. I hope everyone understands that it's good to know to practice all these problems. It's just that you know that I'm not asking